So this first page is going to be basically review. It's going to be a review of putting everything that we talked about this week together, all right? So starting out, let's take a look. There's going to be one little different thing that we add in, but we'll talk about that in a second. So the graph here shows the proportional relationship between the number of candy bars bought. We're going to call that B for bars, okay? And the total cost in dollars. We're going to call our cost C for cost, okay? So my B is going to stand for bars, right? It's going to be on the left side of my table. And that's going to be my X. Except in this situation, we're going to call it B. And my total cost, we're going to call C. But that's just going to be my Y, like normal. So the one thing that is different about what we're kind of pivoting to today is that we're changing our variables based on the situation, right? So bars is going to be B, but it's just X. Cost is going to be C, but really it's just Y, okay? So if I'm looking here on my graph, right, my X, like we said, is the candy bars bought. And my Y, like we said, is my total cost in dollars. So as the number of candy bars increases, your total cost increases as well. And it increases at the same rate because all my candy bars cost the same amount. So just like before, we're going to go point by point. If I'm looking at this first point here, how many candy bars did I buy at that first point? 1. Okay, guys, we got to focus on this, all right? And what was my total cost for that one candy bar?
$2.
$2. For my second point represents 2 candy bars bought. What was the price for those 2 candy bars? $4. We just look over to the Y. This is what we need to know when we get to Alex, okay? You look at the X, you look up, you hit the line, and you look over to your Y. Okay? What about 3 candy bars? What's my cost there? $6. I'm going to look up, I hit the line, I look over. In between 4 and 8 is going to be 6. Sure. 4 candy bars, I look up, I look over. What's my cost there? For 4 candy bars, what's my total cost? $8. You guys seeing the pattern yet?
Yeah.
Good. What about 5 candy bars? $10. We look up, we hit the line, we look over, we get 10. And finally, it's not on there, but 6 candy bars gives me a total cost of what? $12. So what am I increasing my number of candy bars? B for bars. What am I increasing it by each time? 1 plus 1 plus 1 plus 1. What's my total cost increasing by each time?
2.
By 2. Plus 2 plus 2 plus 2. All the way down. Again, none of this is new information. This is what we've been talking about all week. Now we're going to find K. Now normally K is equal to Y over X. But this time, that's right. It's going to be C over B. What K represents is how much money is each candy bar. So we're going to divide the cost by the number of bars, right? So what is my change in C that we found right here on the right side of my table? 2. What's my change in B? 1. 2 over 1. 2. C is cost, so that's going to be dollars. B is in bars. So my cost in the units dollars per bar is 2 over 1. What's 2 over 1? 2. Dollars per bar. Give me a thumbs up if you're following me so far. Good, okay. Again, nothing new just yet. This is what we've been working hard with all week. Now, when we're going to write the equation, again, we're substituting out those letters. So instead of y is equal to kx, we have c is equal to kb. I know that's kind of confusing because it's all a bunch of different letters, but we're not doing anything but just swapping out what letter we're using. So what this equation says is that the cost, the total cost, depends, right? Y is my dependent variable. It depends on how much one candy bar is and the number of bars that you buy. Right? So what was the K value that we just found again? 2. So we could write the equation C is equal to 2B, where my total cost is 2 times the number of bars that I bought. So if you bought 4 bars at $2 each, 2 times 4 would give me what? 8. If I bought 10 bars at $2 each, 2 times 10 would give me 20. And that's exactly what we see in the table, right? Each of my B's just gets times 2, times 2, times 2, times 2. So what we're going to do now is we're going to use this equation and we're going to answer the question, what is the total cost? I don't know what C is. What's my total cost for 20 candy bars? So I do know what my B is. What we're going to do is we're going to plug in 20 for B and solve the equation to find out what C is going to equal.
Yes.
So we end up with C equals 2, and we're plugging in 20 for B. I'm going to drop this down. Am I going too fast?
No.
Okay, I'm going to slow down a little bit. Some of us can already fill this in, right?
Yes.
What would my C be equal to here?
40.
2 times 20 gives me 40. What are my units on that 40? Is that 40 candy bars? No, because what does C represent? Cost, right? I know. I should have picked something different. I knew we were going to get confused with C standing for candy. C stands for cost. So it's 40 what?
40 cost.
Dollars. 40 costs. $40, right? If we're talking about the cost, we're going to be talking about money, dollars. So the total cost for 20 candy bars is $40, right?
Brian gave it to you.
Again, all of that is just a combination of each new lesson we talked about this week. Now what we're going to do is we're going to bring it all together and look at different situations. Here comes the second piece you're gluing in. See all that from them home? All that we just did? This is distracting. Maybe we should do it.
Me too.
Just for sure we're done.
He just stole my glue.
He said I got
I'll give it to you after I'm done. I didn't pay for it.
I'm silly. One more time.
That's fancy.
But they spelled my last name wrong.
What are they? That's messed up.
I know.
It just says Guero
I know.
or Guero. That's too bad.
It's Mason. It's Mason.
They spelled Mason. Yarrow.
Mason.
Yarrow.
Every time I used to walk in there, I was scared.
Oh, here it is.
Nah.
That's lunch.
Okay, give me a thumbs up if you got that glued in. It looks like we all do for the most part. So let's start talking. This piece of paper right here is exactly what you're going to see in ALEKS when we get to our assignment for today. All right? So follow with me. The more you're focused right now, the easier the assignment's going to be, the quicker you're going to get done. Does that make sense?
Yes.
Okay, so let's make sure our focus is 100% up here, and we'll get through this together. So, 3 trains are traveling at constant speeds. What does constant mean again?
Going.
Like,
Keep going.
continuously.
Keep going continuously, repeating the same, right? I'm going to say same/repeating. So the trains aren't speeding up and slowing down and speeding up and slowing down. They're going the same speed throughout. But each of these 3 trains is going at a different speed. So for each train, the distance traveled is D. Okay, D for distance.
And T for time.
And it depends on T for time. All right, so my time in seconds is essentially my X. My distance in meters is essentially my Y. So it means the same thing, we're just using different letters that honestly make more sense for this situation. So in this situation, K is going to represent the speed of each train in the units, meters per second. Distance over time. That's my formula to find speed. And that's something you'll probably learn in science class this year as well. Or next year. I don't know anything about science, but I know in science at some point you learn that. Okay? So let's take a look at these 3 trains. Train A. Our data is represented as a table. Train B. Our data is represented as a graph. What do you notice is missing on this graph that we normally see?
The dots.
The dots.
The dots.
We're going to have to find our own dots, but we'll see how to do that in a second. And my third train, train C, is represented just by an equation. No numbers. Well, there's one number, but no numbers like in our table, no points like in our graph. All we have for train C is the equation. All right? What we're going to do first is we're going to find the speed, again, which is just K. We're going to find the speed of each train. So throughout this week, we found K from a table. We found K from a graph. We found K from an equation. Now we're doing all 3 of them. So let's start with train A. How would I find my value for K from a table? What do we have to do to our table? Do you guys remember? Do the little arrows. That's right, Vincent. We're going to do our little arrows. How do I get from 0 to 55?
Plus 55.
Plus 55. How do I get from 0 to 1?
Plus 1.
Plus 1. Now we only have to do one little arrow because we learn in the beginning that we're traveling at a constant speed. So we know it's going to be the same. Thank you, sir. We know it's going to be the same every time. Okay? So I'm going to put my distance over my time. 55 over 1. Right? What is 55 over 1?
55.
Just 55. And my units, like we said, are meters per second. So every second that passes, this train is going how many meters?
Per second.
What, bro? What?
No, it's okay. Maybe I asked it confusingly. Every 1 second that passes, how many meters has this train gone? 55 of them, right? It's okay. It's Friday.
second.
We're hungry. I understand.
Per second, Tommy. Per second.
It is 55 per second. Go ahead.
So that's 64. He's so for real.
Sonny, let's on run. Come on, buddy.
Do you know? Can you show her? Yeah. If you just go to my point. It says.
I kind of left my.
Yo, imagine
Let's take a look at train B. So train B, we're not going to do our little arrows because we're dealing with a graph, right?
Yeah.
But what we are going to do is we're going to look, just like we did on the previous page, we're going to look at my 1. Okay, I'm going to travel up, 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 up. I hit my line. Even though I don't have points, I see that if I directly look to the left, right? I went to 1. I traveled up. I'm going to travel over. How many meters has train B gone in just 1 second? 50 meters per second. Right? Did I lose anybody? Or we seeing what I did there?
No, sir. I see.
Okay.
I see what you see.
Now, train C is the easiest situation for us to pull our K from. What speed is train C going?
65.
65. It's sitting right there in front of us.
Train B is the slow.
Right? The distance is 65 meters per second times however many seconds we've been traveling. Right? So if I've traveled 1 second, 65 times 1 gives me a distance of 65. Right? Does that kind of make sense?
Yes.
Okay. If not, that's all right. That's what our practice today is for. Now, here's my 3 train speeds. And what we're doing is comparing these relationships. So, which train is the slowest train?
B.
Train B is going the slowest. Train B. Which train is going the fastest?
Train C.
Train C. All we're doing is comparing, but in order for us to compare, we've got to find all those numbers first. All right? Now, this is where people were getting lost a little bit in second period today when we got to the Alex. How far does each train travel in 3 seconds? Here's how we're going to do it. We're going to take it one by one. I'm going to start with train A. I'm going to look back to the information I have. Do you guys see 3 seconds anywhere in this table?
Yes.
Where is it?
The number 3.
It's the last one. What was my distance after 3 seconds? 165. Did I have to do any math to find that number? No, I just had to use my eyes. 165 meters for train A.
Meters.
Everybody see how we got that?
Yes.
Okay. Now we'll go to train B. Train B, where do you see 3 seconds on this graph here?
On the number 3.
On the number 3, on the x-axis, right? Right there. So if I take my number 3 and I look up, 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 boom, I hit the line right there. Where am I going to look to now?
The left.
I'm going to look to the left. Boom, 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 boom.
And
What's my distance now?
150.
150. Okay, I'm going to pause there for a second. Everybody see how we figured that one out?
Yes.
Okay. 150. How's it going? 150.
Early dismissal.
Thank you. I appreciate it.
Me. Right?
They're not here.
See you in 6th period. All right. Last one, train C.
What is that?
Nothing. Don't worry about it. We're worrying about notes.
This is my award.
So train C. This is where we actually have to do a little bit of math. All right. Don't be too upset. It's not that crazy. Train C doesn't give us any numbers and it doesn't give us any points, right? So what can we do? Bao, what can we do? What's that? Oh, do you have the number? Okay, what did you get for the number, Bao? 195. Exactly. How did we get 195? Who can help me out with how did we get 195?
65.
Yeah, Aiden, what do we do?
50 times 3 by 65.
Exactly. The time we're looking for is 3 seconds.
Stretch your hands.
So in train C, I have to plug 3 in for T and multiply. I have calculators for you to borrow when we get to our work. Okay? 65 meters per second times 3 seconds. 65 times 3 gives me 195. Now, which train did we say was the fastest?
Train C.
Train C is the fastest. Did train C go the furthest?
Yes.
Yes, because it's the fastest, right? The faster you are,
The faster you get.
the further you
The
go.
faster.
That's what you meant, right? The faster you are, the further you get. Which train was the slowest?
Train B.
Train B. Was train B's distance the smallest after 3 seconds?
Yes.
Yes, it was. So that all pans out. Train A was in the middle, so its distance is also somewhere in the middle. All right? This whole page right here, right? That's one problem on Alex, and we got 10 of them. I know it sounds like a lot, but once you do a couple of them, you're going to be flowing. You're going to get it done nice and quick.